Hello everybody and welcome to another video. Today we will be expanding on the video called C++ Optimizing Move and Destructor Semantics, where at the end of the call I touched upon a Stb DS header, single file header, where if you want to go really nuclear on optimization, just replace your standard C++ vector with this C header. That is also portable with C++, but there are a lot of things that need to be covered and implemented in order for us to fully integrate with this C header. And this header is essentially just a array implementation, a dynamic array implementation on heap that provides you with macros of array pop, array put, and all the members of a typical array implementation that you would see in the standard vector C++ implementation. But it is not a standard for a reason, because it's quite non-C++ and it's really a C++ substandard to have your allocators defined at the macro level, or your functions defined at a macro level, but they're not necessarily functions. Like we said, it's a macro that, and if we look up, that does something like this. If we look up one of the macros, we can see that it is essentially, we pick up our stdb buffer, we access the header, and the header is literally implemented as a first element of the dynamic array, where we allocate some space for that struct, and each time we would access the first element, we would do the length and +1, because you want to avoid the header. But that's not the objective of the video, to explain the implementation of this single file header library. It's just to cover how, and to dive in how to integrate this with C++ and use it in your C++ code freely. So essentially, if we look at the block file here, the usage is pretty straightforward. You go with a null, you go with a put and push. You can look up what these do in this documentation sort of multi-line comment, where the authors break down what it does. And you can, by the way, freely edit this implementation of the header with no problems whatsoever, and it's clearly stated on their GitHub repository as well, on their open source GitHub repository. And given that they use MIT license, you should be good to go. So this is what is the first thing that we need to do before we integrate this header with C++. We need to look at our use case. What are we trying to accomplish? Are we trying to build a wrapper that follows the C++ RAII rules, or not? And if the answer is yes, beforehand we need to see how to actually use this library in C++ and what are we supposed to expect. So if I take a look at this here, and if we keep tabs on the block 5, we'll see that first we define an array, we initialize rs, and we invoke the move operator. Why are we invoking the move operator? That is because in C++, this here will invoke the move operator assignment, and that's how you get there. And now we can see that we are calling the destructor of s, because at the end of this expression, namely at semicolon, this temporary r value s will get cleaned up as its life cycle / lifetime expires. And now what you would typically do here is, because there's no wrapper, this is just a pointer, this is a C library, you would do explicit free. But then if we look at memory leaks, we're still gonna have memory leaks. Why is that? Now, if you check out the video called C++ Advanced Memory Allocation on this channel, you will notice that these kind of buffers using malloc or any other method, they don't function, they're free. That doesn't function like something like this, where if you have an array and you do delete operator, it will invoke your destructors as well. So you will have to do that manually, where you have a for loop and then you do array length. You need to get the array length, and now you have array +1, and here I'm gonna invoke my destructors implicitly. Now if we check that code out, now there are no leaks whatsoever. So those are the two main factors we have to count in before we move on with the integration of this library in C++. So I've decided to create a namespace called C++ wrapper where everything is public, pretty much. I can just go ahead and use a struct here because they're just, I don't have enough components for this to be a standard C++ class. So I'll just go with a struct, and where everything will be public. Why is everything public here? Because I will not try to define a function such as push, and then I have my item where I would do something like this: array push, array item, and then I gotta do move here. I will still have to rely on the macros just for performance reasons and for the compiler having to do less work. I will not try to create additional member function wrappers here because there's no reason to. I'll just use macros. And I will get to that in a moment. Why am I not using functions? If you check out the video called C++ Optimizing Move and Destructor Semantics, you will see that in a typical standard vector implementation, when we do something like this, where we have a pushback and we move our variable from the current scope into another piece of memory or another entity such as standard vector, we'll end up with having to invoke the move constructor, and we were trying to sort of go nuclear on it where, okay, I don't need to invoke the additional move for performance reasons, or for maybe a lot of people would consider it extra performance reasons, like so yeah. That is why we are not going to create these wrappers right there. So now, when I call or construct my wrapper, it is going to be Stb DS with my template type, which is going to represent the type of the array on heap. And then each time I would call put, which is going to be essentially, it is just a array push. Put, in my opinion, it can indicate that I need to specify my index where I'm going to put this element, and that it would be the index of the buffer. So I prefer to use array push. And then we are going to be guaranteed 100% that this wrapper here will be implicitly destroyed or cleaned up at the end of this current scope. So let's take a step back and do what we did in the video called C++ optimizing move and destructor semantics. I don't like this here. I don't like the move assignment, and I don't like the additional destructor call. Why can't I just have sint and clean up of that int? Because that makes sense. I don't need all of these additional move assignments if I'm just doing that. So in order for us to accomplish something like that, we will need to go back and create another macro where I will name it new place, which stands for new placement, because we are using C++. And in C++, new placement will perform much better than the move assignment. And natively in C++, you would prefer new placement over a move assignment. So new place. And I already have some code prepared. So instead of the move, I will take the header and increase the length, and my value is going to be that of new placement, which is going to be semantically something like this, right? S. So now if I go back to my code, I will call stb array new place. We can say even stb or array put or array push new place, where the first argument of the macro is going to be the dynamic array itself, and then we have the S10. Now let's compile this and run it. Now we have accomplished what we wanted to accomplish. What we wanted to accomplish at first. We have one S initialization, and this S is essentially just a destructor, an implicit destructor call of our array wrapper, or STB array wrapper. Now if we check for any memory leaks, there will be none. So that's how you would integrate your STB respective library into C++ to keep everything consistent and to keep the C++ RAII consistent with your code base. That'll be all for this video. Thanks so much for watching. Till next time, take care.